this stage in the creation of the landing gear doors, we've used a number of Javelin's offerings, including Artec 3D scanners, SOLIDWORKS, and Geomagic for SolidWorks to come up with a print-ready design. The next stages of the production process are design for additive manufacturing, low-fidelity prototyping, and then ultimately 3D printing for production purposes and end-use parts. As a Stratasys reseller, Javelin is well suited to produce parts for end-use applications within the aerospace industry because we work with the Stratasys Fortis 900. Our Fortis 900 printer combined with the Ultim 9085 material is the only combination with a validated path for certification to create parts that may be used in flight. Design for additive manufacturing, or DFAM as we call it, is a process by which we'll optimize an existing SOLIDWORKS design file to be better suited for the 3D printing process. For all of our design and reverse engineering projects, we typically incorporate a low-fidelity prototyping stage. This allows us to validate our designs with the customer without investing too much in production time or materials. Typically for low-fidelity prototyping, we'll work with a thicker slice height and a more cost-effective material, such as ABS or ASA. For our low-fidelity prototyping stage, we're less concerned with material performance and less concerned with material strength, and mostly concerned with near-net shape and mating with assembly features. We're looking at about 5 hours of production time for the low-fidelity prototype. This means we were able to receive the design, get it on the printer in the morning, and actually send it back to the design team before the end of the day, so we get the test fit done and completed next business day and begin working on the overall final product. Wherever possible, we'll leverage our post-process technology support removal systems to allow for easy, hands-free support removal, allowing our team to spend more time on the design and production stages of the project and let the machines take care of what would normally be manual labor. Once we've completed the prototyping stage, we've evaluated that our design will actually meet the requirements of the customer, and we've established a rough idea of a manufacturing strategy with regards to print orientation and supporting features. The next step in the process is to determine a material that's going to be best suited for the end use of the part. For aerospace applications, we always work with our Ultim 9085 thermoplastic. It is a flame-retardant thermoplastic with a UL94 V0 rating, has high performance, is strong yet lightweight, and has excellent heat resistance. It meets stringent test criteria and allows for traceability from printed part back to the raw material, a feature most required in the aerospace industry. The Ultim 9085 boasts superior physical characteristics to the traditional alternative of fiberglass and wood. By leveraging the additive process, we save about 90% of the manual labor required to create these doors traditionally. You can see on the interior of the panel, as well as the pilot holes, we've leveraged angles steeper than 45 degrees in order to prevent support material generation. This saves us both time and material cost when producing the part. The second optimization we performed was the inclusion of stabilizing walls during the production of the part. Each landing gear door is comprised of 2 panels that function independently. Once we have both parts in hand, we'll do a quick visual inspection and assemble the pieces to ensure they fit correctly. After that, the next stop is taking the parts to the aircraft for mounting.